this opportunity to welcome you to today's lesson. I hope you are going to enjoy a lot from this lesson. But before you start your enjoyment, I'd like you to press on the red button there below the video written subscribe. Just press on it, and then you can as well like the video clip. You can as well leave some comments behind for the improvement of the next video clip. Otherwise, feel more welcome to this lesson. Thank you. Okay, this is Mr. Ongeti's Form 1 Mathematics assignment. So this assignment is meant for all schools in Kenya, that is Kenya secondary schools, and the subject teacher who will take you through this assignment is none other than I, that is Mr. Ongeti Keane Martin, and this assignment is meant for the Form 1 class. Just like they normally say that when technology is implemented in the classroom, learning is normally brought to reality, and students are normally empowered so that they can create their own learning future. And that's why we try as much as possible to instill technology among learners, because the world keeps on changing and there's great technological advancement. So this is my contact number, that is 0716029802, and my image is over there. So we normally know that mathematical skills is a necessity in problem solving. Therefore, it's something that is quite unique, especially when it comes to real life situations. At times you may encounter certain problems in life that needs the mathematical skills. Okay, so that's just to encourage you so that you can put more energy in working out mathematical sums. So this is a Form 1 assignment, and the introduction to the assignment is as follows. So this assignment is meant for Term 1 work, and there are some changes or some adjustment that I've just made, in that among the 10 questions we'll be having examples. So in each and every question there's an example that you're supposed to go through before you tackle the questions that are going to follow. So just like they say that these are holiday assignment, and you are going to take it in form of lessons. And as we all know that in most of the lessons that are normally taught in schools by teachers, there are certain objectives that are supposed to be achieved at the end of each and every lesson. So that's what I'm saying, that by the end of the lesson, you learner, you should be able to first of all round off numbers and solve word problems, which are going to be included in this assignment. And then you are supposed to work out LCMs and also perform arithmetics on fractions, which is also included here. Then the third objective is that you're supposed to solve integers and also convert fractions, okay, which is also included in this assignment. And then point number 4 is that you're supposed to solve all the questions that are going to be included within this assignment. So feel more welcome as I begin on question 1. So before I give you the first question in this assignment, I'll look at an example. So example 1. So let's go through example 1 together. So in example 1, we have round off each of the following numbers to the nearest number indicated in the bracket. And the first number that you're given here is 473,678, which is supposed to be rounded off to the nearest 100. Then part B, we have 524,239, which is supposed to be rounded off to the nearest 1,000. And lastly, part C, which is 2,499, which is supposed to be rounded off to the nearest tens. So that's an example that I want to work out. Now let's look at the solution to this example. Now under solution, we'll start with part A. So in part A here, when I look at what we have in part A, we have 473,678. So if I want to round off this to the nearest 100, I'll come and look at the place value for hundreds, the place value under hundreds, that is 6, which is 600 as the total value under 6. But now I'll have to look at the previous number before 6. Now look at the previous number before 6. When you look at the previous number before 6, you'll find that it is 5. It is 7, which is greater than 5. Okay, so because it is greater than 5, then it will add 1 to 6, so that now the number becomes 7, and then the rest remains 0, 0. So our new number becomes 473,700. So this is the answer, which has been rounded off to the nearest 100. Now let's look at the next question. So for the next question, the solution for the next question for part B. Now in part B, when you look at part B, we have 524,239. Now I want to round off this to the nearest 1,000. If I'm rounding off this to the nearest 1,000, then I'll have to look at the thousands digit, that is 4, and then you look at the previous number before the thousands. So when I look at the previous the number before that 1,000, which is the hundreds, I'll find it's 2, and 2 is not 5 or greater than 5. Therefore all these numbers will change to 0, 0, because it will not be rounded off to 1,000, so that we can add it here to have 525. So instead we will have to retain 4, so that the answer become 524,000, which has now been rounded off to the nearest 1,000. Now let's look at the next example. So in the next example, we have part C. Now we look at this part C. Look at part C. Part C reads 2,499, and we want to round it off to the nearest tens. Okay. Now, for you to round it off to the nearest tens, look at the tenth digit. Now the number the previous number before the 10 digits, the ones, and we look at it, it's greater than 5 because it's 9. So it will add 1 on 9, which gives us 0. Then you add 1 again to 4, which is 5. So you'll find the number changing to 2,500. So this one means that when you round off, you'll get your answer to be 2,500. So we can now pick the question. So question number 1, which is the assignment question number 1. You can write it down somewhere in your exercise book. So, or you can write question 1 in your exercise book. And question 1 is there. You can write it down. So you can write it as I read. So question number 1. Round off each of the following numbers to the nearest number indicated in the bracket. Okay? So the first part that you're having here is 322,643. Now I want us to round off this number to the nearest hundreds. Now if you're rounding off this number to the nearest 100, you look at the hundreds, which is 6. Okay. Now look at the previous number before 6, we have 4. So now 4, when you look at 4 is less than 5. Okay, so it means that the rest of the numbers will now change to 0, 0, because they do not the previous number does not exceed 5, or it's not 5. So you can just go ahead and work out that. The next number also try to do the same the way I've just given an example. So we have all those numbers A, B, and C. So you can work out those questions. So let's look at question number 2. So before we look at question number 2, let's look at an example. So An example that you're given here is Otego had 3,469 bags of maize. Each of the bag was weighing 90 kilogram, and then he sold 2,654 of these bags. So the first part A question reads, how many kilogram of maize was he left with? Then part B reads, if he added 468 more bags of maize, how many bags did he end up with? Okay, so that's the example. Now let's look at how we can handle that example. So the solution to this example, so we'll start by saying that one bag weighs 90 kilogram. One bag weighs 90 kilogram. Now, if one bag weighs 90 kilogram and I have 3,469 bags, so it means that for me to get the total weight, I'll take 3,469 bags, then times 90, of which this one will give me 312,210 kilograms. Okay, here, that's the answer. And then let's look at part B. So the next weight is 2,000. You take 2,654 bags. Then you also multiply by 90. Then you'll get 238,860 kilograms. So you can see the weight, the total weight that you'll be having over there. And then if you want the amount of maize that is going to be left in terms of kg, you will subtract. So you'll take 312,210 kilogram minus 238,860. So when you subtract that, you'll get 73,350 kilograms. So that's the amount of maize that is left. Now in terms of the bags, so we'll have 815 plus 468, which will give us 1,283. So we can now take the question. So the assignment for question number 2, you can write this one down. So it's there. Just take your time, put it down in your exercise book. So question number 2, we have a businessman had 1,860 bales of maize flour in his store. Okay, he sold 425 of them. Now after selling 425 of them, the question now reads, how many bales were left? Okay, then part B, if each bale contained 12 packets, how many packets remained in the store? So you can write that question down. Just put it down. Put it down. Then you can go ahead and work out that question. So we can now move to example 3. And I want you to listen carefully to example 3 before you attempt the question for question 3. Now in example 3 we are going to have an explanation, and in this explanation I want you to pay attention. Okay, so we are going to look at some of the 3 numbers. We have classification of numbers. So the first classification here are the even numbers. Now I'll start by asking myself, what is an even number? Okay, now when you talk of an even number, we are talking of a number which can be divided by 2 without a remainder. Okay, so there are some of the numbers that you can just divide by 2, but you will find that you'll always not get any remainder. So these numbers can range from 0 up to millions of numbers. But now I'm only going to take just about a few. Like for example, when you look at 0, 0 is an even number because it can be divided by any number and it can be divided by 2. Therefore, it's an even number. Then 2 is also an even number, it can be divided by 2. 4 is also an even number, it can be divided by 2. and 6 is also an even number, it can be divided by 2. 8 is also an even number, it can be divided by 2. And you'll always find that there are some numbers that normally ends with either 0, 2, 4, 6, 8. So most of them are just even numbers, because in most cases you'll find that these numbers can be divided by 2. So that's what we call our even numbers. Now let's look at the odd numbers. Okay, now when you talk about odd numbers, what do we mean? What should click into your mind? So when I talk of an odd number is a number that when divided by 2 will always give me a remainder. Okay, so the remainder can either be 1, as long as you divide a number by 2 and then you realize there's a remainder, just know that that is an odd number. Just to give some examples, just a few, like for example 471 is an odd number, 123 is an odd number, okay, 1197 is an odd number, 7129 is an odd number. So we have several odd numbers which can also range from 1 up to millions. Okay, so we only have some specific numbers such that these numbers within the range of 1 up to millions or mere trillions, you'll always find that these are numbers which cannot be divided by 2 completely. They must always have a remainder. So the numbers end up with the following digits. So in most cases the numbers will always end up with odd digits. So any number that is ending up with an odd digit, just know that that one is an odd number. Like if the number ends with 1, if the number ends with 3, if the number ends with 5, if the number ends with 7, if the number ends with 9. Hope you're getting that. Okay, so let's go to the next number, that is the prime numbers. I think that's the third classification. Okay, yeah. Now let's look at prime numbers. Okay, let's start by defining what are prime numbers. Of course, you will start from there. Now, a prime number, when I talk about a prime number, I'm talking about a number that has only 2 factors. Okay, it has got only 2 factors, of course. Now, when you talk of these 2 factors, what are they? Now, 1 and the number itself. Okay, you can have 1 and the number itself. What do I mean when I talk of 1 and the number itself? Now, for example, let's take, for example, 2 as our prime number. So you'll find that 2 has got only 2 factors. So 2 has got 1 and 2 itself. 3 has got 1 and 3 itself. 5 has got 1 and 5 itself. 7 has got 1 and 7 itself. 11 has got 1 and 11 itself. 13 has got 1 and 13 itself. 17 has got 1 and 17 itself. 19 has got 1 and 19 itself, and so on. So as long as any number has got only 2 factors that can go through it, then we say that that is a prime number. Now there's something that you need to note. Why is it that when we are talking about prime numbers we didn't start from 1? Why? Because 1 is not a prime number. I hope you're getting that. 1 is not a prime number. And whenever you are asked to list down some of the prime numbers, please don't mention 1. Start from 2. So 1 is not a prime number. Now, another thing that you should also note is that when you are looking at some of the prime numbers and when you are looking at some of the odd numbers, we realize that 2 falls in both cases. 2 falls as an even number, and at the same time 2 falls as a prime number. So therefore we can conclude and say that 2 is the only even number which is a prime number. I hope you're getting that. Okay, yes. Now that I've gone through all these explanation, maybe you can write down this question so that you can attempt. So this is the third assignment. Okay, so assignment quiz 3. Now I want you to write this down very fast. Now as you write this one down, let me read it for you and explain it somehow. Okay, so we have question number 3. Form a number by arranging all prime numbers between 1 and 9 in ascending order. Okay, so you're being told here to form a what? To form a number. You're going to form a number by simply arranging all the prime numbers. So you'll write down first of all the prime numbers between 1 up to 9. Okay, write them down somewhere. Now, once you've written them, they are already in ascending order. So they'll form a number. Which number is that? Okay, now once you've done that, put it aside. Subtract the number formed, meaning that the number that you have already formed and you have put aside, you are going to subtract that number from a number formed when all even numbers between 1 and 9 are arranged in ascending order. So it means you will first of all arrange all the even numbers in ascending order between 1 and up to 9. Okay? Then identify the even numbers within them. Then arrange those numbers also in ascending order. Then you'll subtract the number that you formed at first from this number. Now once you've done that, then add the result to a number formed when all the odd numbers between 1 and 9 are arranged in ascending order. So it means that you'll also form another number again. So you write all the odd numbers that ranges between 1 up to 9, where 1 and 9 are included as odd numbers, okay? And then you arrange them in ascending order, and then you add to the result. Now once you've done that, state the total and the place value of the second digit that is going to be formed. So I want you to state the total value and the place value of the second digit that is going to be formed. And remember, when I was taking you through the last assignment, I say that whenever you are asked about the digit, first digit, second digit, digit starts from the right hand side. Okay, you start counting digits from the right hand, from not right hand, but from the left hand side, coming towards the right. Okay, so the first digit, the second digit, the third digit. But now when you talk of place values like ones, tens, we start from the right hand side going towards the left hand side. So ensure that you've taken care of that. So that is for question number 3. Now let's look at example 4. Now in our example 4, okay, let me take you through these. Okay, there it comes. Oh, example 4, there it is. Oh, so it reads, find the LCM of 72, 96, and 300. Okay, let's now find this LCM. You see, this is something very simple. I hope you've gone through these. Now let's see, there's the solution. Okay, now let me pick my pen. Okay, now so we want to find the LCM of 72, 96, and 300. Now let's go through these. So I'll first of all pick the smallest, the least prime number, which is 2. So I know that 2 goes into 72, 36, 2 goes into 96, 48, 2 goes into 350. Okay, then 2 goes into 36, 18, 2 goes into 48, 24, 2 goes into 150, 75. Then I go to 2 again. 2 can go into 18, 9. 2 can go into 24, 12. 2 cannot go into 75. Therefore, I'll just retain that 75. Okay. 2 cannot go into 9. I'll retain 9. 2 can go into 12, 6. Okay. Then 2 cannot go into 75. So I'll just have 75. Then 2 cannot go into 9. 2 can go into 6, 3. 2 cannot go into 75. So I'll just retain 75. Then I go to 3. 3 can go into 9, 3. 3 can go into 3, 1. 3 can go into 75, that is 25, because 25 times 3 is 75. Okay, then I go for 3 again. 3 go into 3 ones. 3 cannot go into 1, so here we just retain 1, so 3 cannot go into 25. Then I'll come for 5. Okay, so 5 goes into 25. Okay, so here 5 goes into 25 5 times. Okay, 5 goes into 25 5 times. Then I can have another 5 here, so that 5 goes here. So this one will just retain 1, 1, and then here 5 goes there 1. So that now our LCM will be 2 raised to power 1, 2, 3, 4, 5. So 2 raised to power 5. That's our LCM. 2 raised to power 1, 2, 3, 4, 5 times, okay, times 3 raised to power 2, 3 raised to power 2, and then times 5 raised to power 2. Of course, this one you can simplify. So can you work out this? Please press this in your calculator and work it out. Okay, so you can press this in your calculator and work it out, then you get the answer there. Okay, so we'll have the answer for that. And then now the assignment. So the assignment here is as follows, and I want you to look at the assignment. You can write it down for question number 4. So question number 4 reads, we have 3 bells that ring at interval of 40 minutes, 45 minutes, and 60 minutes. If they ring simultaneously at 6:30 a.m., at what time will they next ring together? Okay. Yes, now you can work out the LCM of 40 minutes, 45 minutes, and 60 minutes. Of course, the LCM will be in terms of minutes. You can even change them into hours if it's possible, and also minutes. Then you add it to 6:30, then you'll be able to get the time. So you can go through that, write down that one. Then we can move to example 5. Now, in example 5, we have the number reads, use number line to evaluate -3 minus +6 is equal to, which is always equal to -9. So I want to prove this. Okay, or maybe if we don't have this. Okay, so we want to work out this one. Now if you work out this, we'll have -9. So now how do you come to -9? So in such cases, when you're given negative number, subtract positive number. So we always start from positive side, the positive number. Like here, I'll start from +6, and then I look at where -3 is. Then I'll draw a line in between +6. Okay, let me pick my pen. Now I'll start from +6, draw a line, straight line. Draw a straight line, there we go, up to -3. Okay, so that's where I am. Then I'll be looking for the value of n. Now when I talk of the value of n, I'm talking about the spaces in between. And then because I'm moving towards the left hand side, I'm moving towards the negative direction. So n will be negative, of course. So n will be negative. How many spaces are here? From 6 up to -3. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, so I have 9 spaces. But now in which direction? Towards the negative side. So n will be -9. That's why you are able to see here -9. Okay. So let's look at the question. The question for this. So question reads, use number line to evaluate -5 minus +3. So you can write that one down, then you evaluate it. Evaluate that. So let's look at example 6. In example 6, we have evaluate -12 divided by -3 times 4 minus -15. Everything over -5 times 6 divided by 2 plus -5. Okay, now let's work on this. Now whenever you're given a question like this, what I normally require from my student is that you split it into numerator and denominator. Now let's split these into numerator and denominator, and then we work it out. So we'll start by writing down the numerator. Okay, now when I write down the numerator, I'll have -12 divided by -3 times 4 minus -15. Now if I work out these, I'll have -12 divided by -3 is 4. Okay, multiply this by 4, Okay, so this one will give me 16, then add to 15. So this one will be 16 plus 15, which will give me 31. So the answer to this part is 31. Okay, so in the numerator side we have 31. Now let's look at the denominator side. Now in the denominator we have these. We have negative 5 times 6 divided by 2 plus negative 5. Okay, now there we go. Now when we'll start with division using BODMAS. So 6 divided by 2 is 3, and then negative 5 times 3 is this one will give me negative 15, of course, then plus negative 5. So if you add these two, you get negative 20. So in the denominator side we'll have negative 20, in the numerator side we have 31. Now take 31 divided by negative 20, then get the answer. Okay, now if I divide 31 divided by negative 20, what will I get? So I'll get this. So I'll have numerator over denominator, then the numerator is 31 divided by negative 20. So this gives me negative 1.55, which is the answer. Okay, now that we've done this, then let's look at the equation. Okay, there we go. Now the equation for question number 6, we'll have this. So question number 6, we'll have evaluate negative 8 divided by 2 plus 12 times 9 minus 4 times 6, everything divided by 56 divided by 7 times 2. You can write down that as our question number 6. Example 7. Now in example 7, I want you to do this. Okay, I want you to pay attention as I take you through this example 7. Then I'll pose a question. So we look at example 7. I'm going to talk about fraction. Now we are supposed to evaluate without using a calculator, and in most cases when I normally give out such question, I find some students using calculators. So whenever we realize that you are using a calculator, then you just know that you'll just score zeros. You'll score zeros. Okay. Now to avoid scoring 0 in this question, I want you to follow this. Now I'm going to split these into two, that is numerator and then denominator, so that the examiner who is going to mark my work will not find it so tedious, especially when it comes to marking. See, there are some examiners who are also somehow tired, so they want clean work. So that's why I normally like that my learners normally split the work into numerators and also denominators. Okay, let's start with the numerators. Okay, now under the numerator side, I have this. I can convert it into improper fraction, that is 7 times 1 plus 3, that is 10 over 7, and then minus 5 over 8, then multiply this by 2 over 3. Now I know that the LCM of 7 and 8 is 56. Okay, now 7 goes into 56 how many times? It goes there 8 times, of course 8 times, and then take 8 multiply by 10. Now if I multiply 8 by 10, what am I getting? I'm getting 80, of course. Then 8 goes into 56 how many times? It goes there 7. Now take 7 multiply by 5. What am I getting? I'm getting 35. Now 80 minus 35, what am I going to get? I'm going to have 45. Okay, so 45 over 56, of course. Then multiply by 2 over 3. Now my numerator, on the numerator side, I'll have 15 over 28. So that's the answer for the numerator side. Okay, now I'm done with the numerator, and you see I've just worked it very simple without a calculator. Okay, now let's look at the denominator side. I'm done with the numerator. Let's look at the denominator side. Now on the denominator side, I'll have these. On the denominator side, I'll have 3 over 4 plus 1 and 5 over 7 divided by 4 over 7 of 2 and 1 over 3. Now I'll start by looking at the BODMAS. Now the BODMAS tells me that I should start with of. So 4 over 7 of 2 and 1 over 3, which will give me 4 over 3. Of course, then I'll go to division. So if I divide these 1 and 5 over 7 divided by 4 over 3, I'll get 1 and 2 over 7. Of course, I'll remain with 3 over 4 this other side, which I'll add, and then I'll get 2 and 1 over 28. Now if I get that, then I'll pick the whatever I got to the numerator, which was 15 over 28, divided by what I'm now getting in the denominator, which is 2 and 1 over 28. Now if I divide these two, I'll get 5 over 19. as my answer. Okay, you can also confirm that. Then the assignment to this question number 7 is as follows. Let's look at the assignment. Evaluate without using a calculator. Question number 7. So 5 over 6 of bracket 4 1 over 3 minus 3 5 over 6 then close the bracket. Then on the denominator side I have 5 over 12 times 3 over 25 plus 1 and 5 over 9 divided by 2 and 1 over 3. So you can write that one down and then work it out. That is question number 7. Now let's look at example 8. Now in example 8 I have this. Express as a fraction 0.6666. So this one tells us that 6 is recurring, of course. It's recurring, okay? So at times we normally write it as 0.6. Then there's always a dot somewhere here. So whenever you come across such a question to me that this 6 is recurring and it can therefore be written in this manner, okay? Now let's see how we can work out this. So the solution to this, so you'll first of all say that let r be equal to 0.666. So this one I'll let it be equation 1, okay? Now then if I multiply both sides by 10, I'll have 10r is equal to 6.666. So we'll have Roman 2. Now if I find the difference between those two by subtracting 1 from 2, then I'll get 9r is equal to 6. Now divide both sides by 9. Then when you divide both sides by 9, we'll have 6 over 9, which would give me 2 over 3 as the answer. So the fraction is now 2 over 3. Okay. So the assignment to this question, I want you to do this. Express as a fraction 0.7333. So just like that, I say that this one can also be written as, it can also be written as 0.73. Then this 3 is recurring. Okay, that's how it can be written. So can you work out on that? Now let's look at example 9. In example 9 we have example 9 reads, without using logarithm tables or calculators, evaluate 384.16 times 0.0625. Okay, everything divided by 96.04. Okay, now if you look at the solution to this, I'll have 384.16. Then I look at the number of decimal places, I'll find that on the numerator side we are going to have so many decimal places, therefore it will determine which number we're going to multiply this with. So we look at the number, or what we are going to multiply with this is a million on both sides. Whatever you multiply with the numerator side, you also multiply with the denominator side. Of course, if I multiply these, you can remove the decimal places as follows. This is 1, 2, 3, 4, 5, 6. So I'll cancel this. So all the zeros have been cancelled, but on the denominator side I'll have 1, 2, which has only cancelled 2 zeros. I remain with the 4. So I can rewrite this one in terms of whole numbers as this, as 38,416 times 625, of course, over 9,604 times 10,000. Now this 625 goes here 1, here it goes here 16, and then 9,604 goes here 1, here it goes here 4. So I'll have 4 over 16, of course, which if you simplify you get 1 over 4. Okay. So the question to this, so the question to this is question number 9. which reads, without using logarithm tables or calculators, evaluate 0.084 times 0.0625, everything divided by 0.014 times 0.125. Write this one down. Then we can go to example 10, which is the last question. Now in example 10, I want us to use our mathematical table. Now you can remove your mathematical table from where you kept it. Then once you've brought it closer to you, I want you to open on the side of squares. Just open it up to where it has been written square at the top. Now this is how we are going to look for the square of 4.25. So to read the square of 4.25, look for 4.2 down the column. So at the top there's a column indicated at the top X. So move with it downwards up to the place that is written 4.2. Now once you are there, move to the right along this row up to where it intersects with the column headed 5. So the number in this position is the square of 4.25. And in most cases, you always find that this number is 18.06, which means 4.25 squared is equal to 18.06. That is if it is rounded off to the nearest 4 significant figures. Now the question to this is question 10, which is find the square of 7.35. Find the square of 7.35. And thus mark the end of our assignment. Okay, learners, I hope you enjoyed the lesson, and most of the concepts that were being explained, you are in a position to understand them. Now, before you leave the video clip, I would like you to press on the red button below the video clip, rate and subscribe. Just press on that. You can as well go ahead and make some comments, and at the same time like. There's a place there written like. You can like the video clip. Otherwise,